I will now describe the concept of optical clipping, or why you have blur when your refractive state is negative. And most electrical engineers will understand the circuit. There is the 100-day time constant control system. As long as that voltage is positive, more positive than that signal, the accommodation signal goes through to its control system, to its long-term control. But if this becomes negative or nearsighted, then this circuit will cut off the positive part of the control signal, of the accommodation signal, which means you have blur on your Snellen. Does a completely automatic focus camera will still have blur if the refractive state becomes negative. This is to simulate an all automatically focused cameras and explain why they have blur at distance, or the eye becomes too long to continue the analogy. But that's not exactly it. But it shows that as long as the refractive state is positive, you'll have 20/20, which is my major point. But this is critical to understand that a completely normal eye can have a negative refractive state and blur on your Snellen, because it is a control system, and that explains the blur. As long as you keep this signal approximately zero, the refractive state remains positive and there's no blur. Only long-term negative here will cause this to become negative, and then you'll have blur because it's a control system, and that's the reason for it. A good electrical engineer will understand this circuit and the effect of clamping. Positive signal value versus negative value. It clips off the signal you don't want to be clipped off. Any questions? That's the concept of a completely automatically focused camera. And thank you.